this is going to be a really quick session. I'm going to show you an example of a validation, custom validation, and then you guys can kind of go crazy with that and implement a few others on your own. Okay, so what we're going to do is, and you don't have to actually do this. I'll just write this and check it in, and you can use it as an example for your own. All right. I'm going to create a new package called validators. New package called validators, and I'm going to make a new class that's going to validate my employee constraint. So I'll just basically what I'm going to want to have at the end of the day is I'm going to want to annotate my person class as an employee, and therefore I'll have certain constraints around what employees should look like. Right? So I'll just call it employee is going to be the name of this thing. Except it's not going to be a Java class. It's going to be an annotation, an at interface. Oh, sorry, I screwed up the package name. Kind of contacts. There we go. Okay, so let's talk briefly about some of this stuff. So first of all, let's just talk about this part where we say public at interface employee. That means we're declaring an annotation, right? We have, and I'm sort of working my way from the bottom up to the top here. We have a retention policy of runtime. What does that mean again? We talked about this earlier. Does anybody remember? Retention policy of runtime. Or why would I need to say that I'm retaining an annotation at runtime? AOP. Yeah, good thought. Sort of. Well, reflection is the simpler answer, right? We need to be able to see at runtime that a class has this annotation, right? If a class is annotated with employee, it doesn't do us any good to just see that at compile time. We need to know at runtime so that we can check instances of it, right? So that's what retention policy is about.
But why would there be even an option to have it not available?
Good question. Let's think of what would be another very common Java annotation that's just retained for compile time. Override. Yeah. Yeah. Override. You don't need it at runtime at all, right? It's not useful for introspection. It's only a compile time annotation. So.
You don't specify. Does it assume that it is at compile time?
I don't know. That's something I feel like I should know, but I don't.
What is that documented?
That one I actually don't know. I was going to get to that last because I don't know what documented means.
But needed?
It is needed. Oh, here we go. And indicates that annotations with a type are to be documented by Java. Oh, I guess okay. So classes that are annotated as well, that's a little bit goofy. I guess it's probably not needed for this.
It's not needed, actually.
Yeah. All right, fine.
This is all Java, right?
Yeah, this is all just pure Java stuff, right? This is not Spring. This is not Hibernate. This is not even Java EE, right? The stuff that I'm showing you so far. This is Java SE. This is just standard Java. So retention policy. We've got a target that says what kind of things this annotation is applicable for. So we could say that this annotation is applicable for constructors only, or for fields only, or local variables only. Well, in this case, we're going to say it's applicable for type declarations, meaning classes, right? So we'll specify that person is going to have the employee annotation, right? Person is a type.
I'm sorry, what is type represented?
it means that this annotation is going to be applicable to type declarations, specifically class declarations,
Oh,
right? Class declarations or interface declarations, right? That's what we mean by type here. Now this is our Java EE stuff coming in, right? This is our Java x.validation. It says that this annotation represents a constraint that should be validated by something I haven't copied in here yet, something called the employee validator, which we'll see in a bit. But basically the way validation always works is sort of in two parts. You say which things should be validated, or like what the validation should be, right? And then separately, not in the annotation, right? Because annotations can't actually have any code in them. Separately, we have to have a class that says what the validation actually means, right? We have to implement the validation in a separate class. So very common to just say, employee and then employee validator, right? We need to have these three fields. This is, I guess, sort of magic. Basically, the validation API requires you to have, even if they're empty, it requires you to have a list of groups and a payload. And I don't even know what these are. The message is the thing that I think is sort of most important, right? In other words,
mandatory?
uh, yeah, all of these are mandatory. Yeah. Yeah, I was surprised to find that out. I was like, oh, I don't need these at all, so I'll just omit them. But
Well, the reason I ask is I have something similar and I don't have it's empty basically.
does it work?
Oh yeah, it's been working for a couple of years.
Does it still
That's why I
work?
wonder.
The only difference
Is it using Java X validation, or is it
yeah,
something else?
No, it's Java land. The only difference I see that I don't have add constraint annotation, but I'm using add decorator.
Oh, okay. So this is a different some different framework.
Different framework?
Yeah. This isn't the Java validation API. This is something else that you're doing.
Well, this is Java lang annotation.
Yeah. Oh, okay.
Okay.
All right. So Java validation, yeah. So it requires us to have a message that says what the validation means, right? Manager, yeah. So in this case, we can say manager and employee must work for the same company. That'll be my example here, right? And so that's sort of the behavior that we're going to want to enforce in this employee validator class. So let me, like I said, the way that we do some of this stuff is copy and pasting from previous examples. So that's exactly what I'll do. New class employee validator. Right. So let's take a look at this employee validator now. This is a regular Java class, right? But it implements a particular interface called constraint validator. A constraint validator can be initialized with some sort of state about the annotation that it operates on. Right. This is basically reflection stuff that we're doing. So we pass an instance of this employee annotation in because maybe it has some fields that we care about, right? Maybe the annotation says something like not employees, right? We had mentioned in our list of examples over here that maybe collection length. So we would have an annotation like length value equals 5, or min equals 5, max equals 10, or something, right? So that'd be an example where we would actually need the instance of the annotation so that we can get its fields, right? For us, for our employee validation, we don't really have any fields, so we we initialize our validator with nothing. All right. And then we have an isValid method, which takes the target object, the thing that this validation should apply to, a person, and also something called a constraint validator context, which you can again get some other just information from where we're not gonna need it here. So from this point on, it's just plain Java. From this point on, if I want to say that an employer and a manager, or sorry, an employee, like somebody and his boss has to work for the same company. So I take a person, I get their manager, and I make sure they work for the same company. I just return true or false. So if it returns true, then that data is valid. If we return false, the data is not valid. So it's as simple as that, right?
One question. So you said if you were to validate any of the fields of the person, then that would go under initialize?
The fields of the annotation itself, right? Like let's say, so here let me expand this example a little bit. Like let's say I have a field that's like list of person people, something like that, right? So I have a list of persons, and I want to say that I have a minimum number and a maximum number of persons, right? So the thing that would go into initialize is this instance of the annotation, so that we can see what are the values of these things. So that's what would go into initialize, and then what would go into isValid would be this object, the target.
And we would define those min and max as private data members in that class, and then compare isValid.
It'd be in the annotation. So the way, and this is a little bit weird. Basically, the way that annotations work in Java in general is a little bit weird. If I want to declare that an annotation has some properties on it, I make them look like methods. So I would have, for example, int min default 0 or something like that.
And these would get initially called when you specify it in the length.
And these, yeah. So then when I want, I could say employee dot, and you can see the things that are in there, right? Payload, and so on. Right.
Then you would set the value to whatever value you want.
Right.
To the value that is.
Right. Exactly. So this is a simple example. I'm going to apply this now to person, right? We're going to say that person needs to be validated as an employee, right? And so this, sort of from the usage perspective, like this is very simple, right? A person must satisfy the employee constraint. Maybe this isn't that well named, but and we'll add some stuff to it in a bit as well. So let's run this. Let's run. So the constraint that I've implemented is that a person and that person's manager must work for the same company. And I think I've got a bug in my implementation, so maybe one of the things you'll need to do is to fix it. All right. We've got Tesla, we've got Dan. All right, first things first. Can Dan be his own manager? Uh-oh.
Okay. We don't have any.
Oh, because we don't have an employer. Wait, no, that's sorry, I got confused. I was thinking of a different validation, the acyclic validation. Yeah, sorry. Yeah, that's fine. Man, my brain starts to turn to mush at this point. Okay, so we need to add a new company then. Maracana. Let's add a real company for a change. Okay, so And let's add yet another new company, Cisco, or dog. All right, Tesla works for the company of dogs. All right, so Tesla is employed by dog. All right, Dan is employed by Maracana. Okay. If we then also say that Tesla is managed by Dan, there we go. Okay, so a couple of things that we see, by the way. Remember that we had specified our method as transactional, right? We did that transactional annotation. So the first exception that we see is could not commit the transaction. There's a nested exception, rollback exception. And if we scroll down, we should see finally that the root cause, well, let's go all the way down here. The root cause was this constraint violation. Validation failed. Manager and employee must work for the same company. All right. Cool. So, I mean, it's a little bit weird looking. I mean, mainly not because the Java EE stuff is weird, but just actually because annotations in Java are weird. So that's why we spend a little bit of time looking at the just getting familiar again with the syntax here. But basically your task is going to be to take this employee annotation and expand its use a little bit. So you don't need to actually do anything with the annotation. You're just going to implement some additional validation in here to see that the employee doesn't end up working for itself somehow. All right. So that's going to be your task is to enforce that this is a directed acyclic graph of employees.
Doesn't work for himself,
Yeah, either directly or indirectly.
That would be pretty straightforward. Right? You just say employee.
Write the code. Go.
That's just one line, right?
Well, it doesn't work for himself directly is easy.
Yeah.
Doesn't work for himself indirectly.
Yeah.
You need to do something.
You need to keep traversing.
Yeah, you need to actually traverse up. Sorry, I haven't checked this in yet. Let me do that.
Can you add recursion?
What do you mean?
Is valid. Can you make that recursive?
Sure. It's just Java code.
So at the end of the day, somebody's going to work for himself, right?
Why?
You won't have a manager field.
With what?
You won't have a manager field. You won't-
The head of the the DAG, right? Who's he going to report to?
Nobody. No.
Oh, I see.
Yeah. I think my current code for is valid is actually slightly buggy as well. Because like if I have no employer but I do have a manager, that's weird.
If you
Yeah, so that's actually sort of another bug. Let me get that on the recording. Yeah, so the question was basically about, well, what do you do if you get an exception like this? Like right now we're not, right now we have no fallback for if the constraint wasn't satisfied, right? Well, I mean, the short answer is what happens when a constraint isn't satisfied? We get an exception, right? So what you need to do in your controller is handle exceptions. Right, so person controller is trying to save a person.
Yeah, so it eventually bubbles up to there.
Yeah, I mean that exception comes through here at some point. So you would do a try here.
Over the save.
Yeah, over the save, or I mean, over any of this stuff really. So you would do a try. You would catch.
But it's
You would catch some sort of exception. It wouldn't necessarily be a constraint violation exception. Right, we declared this method as transactional, so we saw that the exception that we got was actually a rollback exception. So basically any exception that you catch, you probably want to do something with, right? Whether it's a constraint violation or or whether it's an optimistic lock exception, or I mean anything, any exception that gets thrown inside your business logic, you probably want to pop up some. Redirect to some view that's like, yeah, it'd be a different redirect or flash or something like that. Yeah, yeah. At that, the good news is like at this point it's just Java. We don't have to do anything special. Yeah. So that's a good question. Like I like being able to say it's just Java. Because that's sort of as opposed to it's Java EE magic or it's Spring magic or it's Hibernate magic, right? If I say it's just Java, that's basically NEPA is happy because we can debug, right? Yeah. So although we said it's just Java. Let's there was sort of a catch. Not really a catch. Like basically, if you want to, like what I was going to start out saying is like basically in any of these methods, there's the possibility always that there's going to be some exception, right? So even in like get edit person, right? It might be that we can't connect to the database for some reason or something. So let's say we want to show some generic error page, something like that, and we
person controller, but everything.
and yeah, we want to do that for everything, and it'd suck to just have a repetitive try catch block in all of our controller methods. So that's again like what does that sound like a job for? AOP, yeah. So there's a few things that you can do. Possibly the easiest thing is not even necessarily AOP, right? Right. AOP would be if I annotate my methods with certain like exception handlers. We can do even just a blanket. This I don't know why it's called a handler exception resolver. I would call it a error handler resolver or something like that. Or exception handler resolver, but basically it maps exceptions to views.
rest of these sections go to this view.
Yeah, yeah.
So it's like, it's not in itself a catch-all, but you can make it such.
Yeah, you can, exactly. So some of these are just kind of standard, like trying to be sort of restful, like HTTP media type not acceptable exception or whatever. So those are already handled, and then you can register your own as well. Or, again, you can do this AOP style, this exception handler annotation, right? Yeah, so that, oops. Anyway, this stuff is all in that link that I posted. All right. So here, let's fix my code is crappy. So let's fix it. What do we need to do? We want our relationships to be acyclic, and we want these things to apply. Let's see. I can't even think about this. So we'll do it in some code comments, right? Must only have manager if employer is non-null, right? If you don't have a job, you can't have a boss. I guess that's a good thing. Employer, or sorry. Person and manager must have the same employer, and person must not or have itself in the clean closure of managers. Right. So that's I guess that's my that's my pseudocode. So what does this need to look like? So if employer, sorry, if let's see, company employer equals person dot get employer, right? If employer is null, if the employer is null and let's see, sorry. If the employer is null and the manager is not null, then return false. Well, if the employer is null and if the manager is not null, then return false. Otherwise, we need to return true immediately, right? So that's much better, right? So if the employer is null, then the manager had better be null. All right, so now we get down here. All right, this is Dan trying to write code after teaching.
Is that necessary, right? Because there are other constraints, right?
There are additional constraints.
Even if the employer is null, there could be additional constraints, right? That's not.
I think no. I think this is the sort of the base case. All right. So if the employer is null, then the manager had better also be null. All right. If the employer is not null, then we can keep going, right? If manager is null, then we're okay. If we work for a company but we don't have a boss because we're the CEO, that's okay. And then I think what I can do is actually turn this into a while loop while manager is not null. If person equals manager, return false, return true. Oh, but we haven't said they have to have the same employer, so I got to do that one too, right? This method is doing too many things.
We shouldn't be just comparing objects, right? Just doing equals on the object.
Oh, just using equal equal?
No, we should be comparing the IDs, or this also works?
Dot equals should hopefully work. We hope. So that's going to be a question maybe. Right? Because we haven't actually implemented equals or hash code for anything. Yeah. Okay. I guess before we get into this, we also need to check, if employer dot oh no, we don't know if we have a manager. Shoot. All right. This is ugly. All right, so if the person is their own manager, otherwise I need to say manager equals manager dot get manager. Yeah. So I guess I could do this as a for loop actually, right? Yeah, whatever. So if person equals manager, then that's no good. Or if the person's employer is not equal to the manager's employer, then that's no good either. All right. So I think this code is correct. All right. We'll go and update the description here. So manager and employee must work for the same company, and employee chain must be acyclic. Right. All right. Okay. So let's try it. Let's try it. We'll implement one additional validator for fields after this, and we'll call it a day. All right. Contacts. All right. Add a new person. Dan. Add. All right. Oops. If I specify Dan as his own manager, that won't be okay, right? So none. Let's add a new company called Maracana, I guess. Well, it'd be a lot easier if I didn't keep cleaning the database every time I run this thing, because I'm not actually changing the database schema or anything. Well, all right. Back to contact list. So we've got Dan. Get a person, Dan works for Maracana, and that should be okay. Actually, let's do this one again. There should be, oh no, it's only going to be one problem. We'll only be able to see one problem. I've conflated the validations here somewhat. If we wanted to be really cool, we would have 2 separate validations, or maybe 3 separate validations, right? There were 3 separate cases that we checked in that one validator.
You would have to put 3 annotations.
So we would just put 3 separate annotations, and the benefit that would get, I mean, it's maybe a little bit clumsier in the code, but it's also more explicit, and it would let us see explicitly which of those things were violated, right? I would like to be able to see, first of all, that Dan can't report to Dan, and second of all, I'd also like to be able to see that Dan can't report to anybody if he doesn't have a job. Right. All right, let's go back to add Tesla. Let's say the Tesla also works for Maracana. All right, so we've got two employees of the same company. Tesla is going to work for Dan, so that's cool. We'll go back to Dan and say that Dan works for Tesla, which I guess is actually sort of true. Okay, so we get our exception there too. Right. So this, I mean, I guess the point of this exercise was that this is just Java. This is pure Java logic, so you just have to know how to program. Right. You don't have to know any Spring or any Hibernate. You just have to know how to write code, which I guess I do sometimes. So your last assignment for the day is going to be to implement a validator not with a different target. The target is going to be a field rather than a class. Okay. So the validator is going to be where zip code. So zip code validator is going to work on, so its target is going to be of type field, right? What type does it operate on? What are the types of our fields? Yeah, just strings, right? So it's going to be a validator for strings. And we want to basically just check, I guess just check that it's a simple zip code. So five digits. So that's going to be the last validator for us. Record here. Implements constraint validator, employee in person. So what does that mean? Employee refers to
The interface.
The annotation, yeah, the add interface, yeah. So it refers to the annotation. Person refers to the target, yeah, the thing that you're trying to validate, yeah, right. So your zip code validator will be a constraint validator for the zip code annotation and string, right? Yeah. All right. So I'll just call my annotation zip code. What's the target? Yeah. Field. We could also say that the target is also oops. Whoa. Oh my god. Eclipse is really freaking out. oh my god. Eclipse is not being useful for me right now. We could say that it applies to methods also. Yeah, if if we wanted to annotate a method as like this, that'd be okay. We'll just keep it simple. We'll say that it applies to fields only. Whoa, whoa. All right. And the message is going to be zip code must be 5 digits.
And all numbers.
Digits, yeah, numeric digits, I guess, or numeric characters, right? Zip code must be 5 numeric characters exactly, and then our zip code validator. Zip code validator is going to be pretty simple. I'm just going to delete the whole body of this, right? So yeah, I don't know. What names did I have here? Yeah, I guess that's fine. Okay, so we're going to initialize with nothing, I guess. We could, if we wanted to have a little bit of fun, we could have a field inside the zip code annotation that said how many digits it should have, I guess. Yeah, minimum length or maximum length or something like that.
How do you do that in the initialize?
In the zip code annotation, we would have a int length, right? And then we would say, right? We would do it like that. I won't do that. We'll just say it's always 5. All right. So how do we write this? Oh,
You need to do an
yeah.
exception handling.
If string length is not equal to 5, then return false. And then
Integer dot parser.
oh, yeah, you could do it that way. But oh no, it's not. It's no good because it could be a negative integer. The first character could be a dash. I think I need to do a for char c in string.
So integer won't parse it if it's negative in the string?
Yeah, sure. Yeah, integer.parseInt on a string like a negative value. Yeah, that'll work.
Java doesn't have API to say alphanumeric or something like that.
Whoa, what just happened? I need char array. Where did that go? Get bytes? How did? Oh, you did it with parseInt, right?
Yeah, I did it with parseInt.
To char array. There we go. I knew that existed. All right. I actually want. Like that. And then if c dot is digit Yeah, there we go. If it's not a digit, then return false. Otherwise, return true. Oh, wait, really? All right, fine. There we go. I think that's what I need. So that's my zip code validator and my zip code, and I need to go back to the address entity. And I don't need the not blank annotation anymore. I don't need that validator because this one sort of subsumes it, right? Zip code. I could have a state validator. You know, you can see that we can have all kinds of silly validators if we want to. Right? So let's make sure it works as usual, and then we'll get out of here. Come on, go, 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 go. All right. All right, let's add a new person. Dan. This should work. This looks like a valid zip code. Let's try it. Oh! What did I do wrong? You said yours worked, right?
Mine worked too.
What did I screw up?
You can find the matching validator class.
Couldn't find the matching validator class, yeah.
Something wrong with the syntax.
Oh, I think I know what I did wrong. No? No?
Employee validator.
Employee validator, yeah. Yeah, there we go. All right, let's try it again. Okay, try this again. Here we go. All right, good. So that 94608 is a valid zip code. That shouldn't be. All right, that's good. That also, yeah. All right. Cool. All right. It works. All right. I'm tired. I'm ready to go. Do you guys have any questions on validation? Data validation? Right. This, you know, the whole idea about data validation again is that some validations we can represent in our DB schema. That's always a good thing. But some we can't. Some are sort of more dynamic behaviors in that. So that's where these come in. Okay. Feel useful? Feel like you can actually use this at some point in your life? All right. That's always a good thing. Okay. Thanks, guys. I'll see you in the morning at 9:30, and we'll talk about REST services a bit. This, you know, I guess a couple of you are signed up for the Java Web Services course, so some of it's going to be actually duplicated. I'll, you know, spend some time talking about what REST services are all about. So maybe you already know.
So in the REST service class also you go through using Spring?
No, we'll be using Jersey.
Oh, Jersey.
Yeah, Jersey and Jackson. Like I said, that course I'll be teaching in a couple weeks here is mostly like a theory course. Part of it will be introduction to the JAX-RS standard, which Jersey implements, or which like REST Easy also implements, right? So if you've seen that, then maybe you don't need to take the course. Like it's probably old news at this point. But I will be talking a bit about, or I mean quite a bit, I should say, about good REST service design, or at least, you know, again, my opinions. I know you guys like schemas, but I don't, so I'll try to sell you that idea. All right, so that's the plan for the morning, and then we'll get out of here before lunch tomorrow. All right. Cool, guys. See ya.